once you click that link, you should make a copy to your own drive. Or if you already have, you don't have to repeat that. So a brief review of yesterday, what we covered. So basic usage in CoLab, you have a code cell, text cell, and you have a runtime that you can run all, or run before, or run selected if you select cell, or you can even run after. So, and there's a table of content on the left, the one I'm using my mouse highlighting. So there's also the triangle. We can minimize that. So chapter 1, whoops, why it's not doing anything? Oh, it looked like somehow CoLab take a second of latency today. maybe because there's a lot of people using it. So, and R is a popular language for data analysis. R and Python are two popular languages. Python is very popular in industrial. R is very popular for research purposes. So, and we can use a simple calculation using variable and equal sign as an assignment, or pound sign is comment. We can this is that, so we can use the smooth princess as an assignment to list, but the indexing of the list is the square bracket. Function of R using a smooth princesses, using a question mark can help to look for helpful function menus. We can use a library to load a written library developed by other people. And then we can load data into data frame. Picking rows using a square bracket, using a comma. The number before comma is a row. Number after comma is a column. We can also use a dollar sign to index the column. And there are also fancy syntax using tidyverse and using that percentage, greater than sign percentage as a pipe. So we also briefly mentioned the t-test, the statistical test, what it means. The general rule of thumb, 0.05 or 1 out of 20 is a cutoff. Although it's really debatable what really useful that p-value is. But in general, I think for most of you in college, that's still useful. Okay, so the next part, we actually read the Johns Hopkins COVID-19 data into CoLab as a data frame. We actually have to install some package. In this case, I'm going to run everything before. Because otherwise it won't. So while it's let running, and then I click that run button to run the current one. Good. So there are people also providing helpful information in the chat. Okay, then we can load the Johns Hopkins data directly into CoLab, into a data frame. A data frame is a basic unit, like a spreadsheet in R. Okay, so we load that data. And then, well, that's just picking the rows and columns. Oops. Because the Johns Hopkins data has the dates, each day as the column, but when we analyze, we want to analyze each county, each location. So we rotate that data and then add meaningful names. So we rotate we pick on only the values of the cases, and then we rotate it, and then we add meaningful column names. We also convert the date into the machine readable format. And then we filter a time window. And finally, we can plotting it, a time window, using a fancy plot called ggplot. For now, you can just consider that's an additive way of plotting. You heard about this 3D printing, and that's called additive manufacture. And because in previous way, we only cut material out of it. So and this plotting function actually also consider something called additive plotting, because we have this specification, then we add something, add another feature, and then add more features. So this is additive process. Kind of interesting, both in the manufacture and in computer language. And now the advanced feature is considered the additive function. So okay, so this is what we start yesterday. Today, we're actually going to analyze where use Chattanooga, Tennessee as an example. And the idea is we use Chattanooga, Tennessee example, but you can modify to study another places, say Puerto Rico or Texas. So you see here, I say define a specific county, and then I also say change here for your own project. And this is where you should change when you start working on your own project. So in this case, Chattanooga is that county Hamilton. The state is Tennessee. And in the Johns Hopkins data, the full combined key, the column name is Hamilton, Tennessee, US. So basically, those are the things you need to change later on if you say work for a different location. You need to know what county, what state. Hopefully, you are all from US. So okay. So once we have those keywords, we can. In fact, Hamilton is actually not a unique name as a county name. We actually can find out how many Hamilton County in the U.S. Oops. I didn't click the previous one. Let's hopefully. Okay, in fact, there are 10 Hamilton counties in the USA. So I have to call Hamilton, Tennessee to specify which Hamilton County we are looking at. So in this case, remember we changed all the cases now into the vertical. Each county is a column now. So Hamilton County must be somewhere in the middle. So, but how do we find out that Hamilton County? Well, let's first look at the time window. Right now, there are so the data is from January 22nd all the way to yesterday. How do I find out the most recent data? I can use a tail. So, oh wow, look. Today is the December 20, so yesterday is December 19. If you recall, yesterday when we analyzed the most recent data point is December 18. So, yeah, so this is certainly an ongoing data set. We can now pick pick only the county we want and select just the county, the county state USA. What is that? That is this, Hamilton, Tennessee, USA. So there. So now, actually there's some warning, let's ignore it. So now we have just the column of Hamilton County, Tennessee, and the dates there. So if I look at the most recent data there, tail. Yeah, it's also December 19. Wow. Is that correct? Hamilton County now had 23,691. The good thing is there's no increase from yesterday. That may be an artificial because people probably didn't work that much on a weekend. So it probably just means there's no one working on the weekend to report it. It's not necessarily the case. So unfortunately, when we do data analysis, you have to take into the data is not perfect. And this, if we actually look at the data on the surface, that means there's no increase on Saturday. But remember, people have to collect testing those data. So the more likely reason for that to happen is human didn't work on a weekend. The virus probably really don't care. For the virus, probably there's no break. The virus just keeps spreading. So it would be nice the virus can stop on the weekend though. So yeah. Okay, so and we actually can pick a time window. In this case, let me see. Are we following? If you are following. Oh no, I see a red no. Okay, for the person who picked the red no, can you let me see? There are breakout rooms. You can join a breakout room. Let me see. Can you join the first breakout room? There's a TA there in the first breakout room, and so when you click more, you will see the breakout room section.
I can't really find the breakout room.
On the control panel, when you click more, do you see the breakout room?
Nope.
Oh, then maybe you are using an old version of a Zoom client.
Probably.
You exit this meeting, update your Zoom client, then come back.
Okay. Yeah.
All
right.
Okay. Okay. So I mean, in the meantime, so while that student is talking with, trying to talk with TA, I'm going to move on here. So now I'm going to select a time window, trying to plot it. So here we are selecting a time window from April 1st to October 20th. Actually, let's just select December 19. That would be more recent. So in fact, inside of head, we can also use tail just to make sure it is December 19th. No. Something is not right. I changed that, but why is still not saying? Okay, now I need to rerun the previous one, I guess, yeah. So, okay, so, and then we are going to plot this Hamilton County, Tennessee in that time window. So, wow, okay. So, you can probably see there are 2 points because the Friday and Saturday have the same number there. In fact, early in January, minus in Tennessee will stop a mass testing and change it to voluntary self-testing something. So if so, in early January, my expectation this testing capacity will goes down, and then of course the confirmed cases probably will also go down. So, but that's just another issue to consider in January. So, okay, okay. So, so what we have go over is basically chapter 3. Chapter 3 and chapter 2 is actually pretty similar. The difference is the chapter 2 we using indexing. Chapter 3 we actually specify a name, Hamilton County, Tennessee, to look for it. Other than that, technically they are the same, basically plotting of the cumulative cases. But that's it. The cumulative cases very often is not that informative. It's really the daily cases change, the trend of the cases is more interesting, at least from epidemiological sense. So chapter 4 is a chapter trying to, from the cumulative case, we're trying to analyze the daily cases. So again, we are going to define the name of the location. So here, change here, I guess change here to your home county and state for your own project. So in this case, we are going to use Hamilton, Tennessee, US again. And here, so even though I have spent all the chat, but that's all we needed to actually retrieve that data, Johns Hopkins data, and then just get the location. So if we run just this block, is actually going to read the Johns Hopkins data and then convert all the cases into a matrix and rotate it, and then add the column key, a column combined key to the new informative column name, and then we convert the date, pick a time window, and then select the location, and so that's and then we have actually the location data. So even though we spend 2 chapters doing that, but that's only the code actually needed to do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code. In fact, you can even simplify it furthermore. So about 11 lines of code will just get retrieve the data from the Johns Hopkins website and convert it into the data frame in R with the location of the column, and then select the Hamilton County, Tennessee. So and then the next job is to a task. We convert this cumulative counts, the cases number, into daily cases. In R, we have the function called diff, probably short for difference. So that name actually probably there for historical reason, because in computer language that the differ function has been used quite a lot. Say, it looked like there are some interesting conversation in the chat window. So, yeah, it seems TA also responding to the question there. So, so if you first started, so how do the differ work? So this is the remember this is Hamilton County, right? So the cumulative cases with the first column, it start from 0, and then we have the first case. I remember that's a big news. And then for a few days, you had the first case, and then 3, 5. Now it's the 23,000. And it turns out we can the differ function, we just calculate the difference between the cell and the subsequent cell. So if I say differ TB subsequent column, it's basically, look, the last day, last number is 0 because the Saturday and the Friday, there's no difference. So it is 0. Well, the first few days is also 0, but then after 1, 2, 3, 4, 5 days, and then it becomes 3. So there. So is that 1, 2, 3, 4? After 4, 0, 1, 2. Yeah, after 4, 0 is increased by 2. And then there's a 5, so another increase by 2. 5, 5, now it's 0. So there, so we have convert the cumulative number into the difference. Now, because if you calculate difference, then there's one of the days will be missing. So we assign the first day as a 0 as well. Right, the first day is 0 compared to 0 itself is also 0. And so basically, we add 0 to the first day because otherwise it's going to have one less number. So, and then we can just make the daily cases into a data frame. There, that's the daily cases. And then we can also add the dates there. So the dates basically, we actually could just convert the old dates there, but what I did is convert the row name too. So there, the dates is the year, month, and the date. So that's not the American tradition. It's more like systematic. I think in the U.S. only the military use this. So some people also said this is the military standard. So yeah. So and then we can also add the row name back into the data set. Oh, I didn't show that. If I add the row name back, do a tail again. I don't know. Yeah. So, okay. That's the local daily cases. That's the year, month, and the day. And the last day, December 19, we have 0 cases there. Yeah. But we may, instead of just call it a local daily case, we may actually call it a county name just to be more informative. So there, basically, I renamed the first column name back to the location. So now we have the the daily cases for Hamilton County, Tennessee. Yeah, you could go back and do a verify yourself, but in this case, we know since Friday and Saturday has no change, so we know that Saturday is 0 increasing. So in reality, probably the Saturday and Sunday case will be moved to a Monday reporting, Monday or Tuesday. Usually it goes to Tuesday because that's actually, if you really look at the daily cases, it looks like there's always a peak early in the week. That's mainly because during the weekend, people don't work as hard as they are on Monday and Tuesday. So many of the reporting will be postponed into Monday and Tuesday. And very often, if people work on Monday and Tuesday, reporting will peak. So it's actually quite interesting. Look at the daily cases reported. So. Okay, so and then we can now actually plotting the daily cases, see how it look like. So again, we are going to do a ggplot. Remember, ggplot is additive. So and the nice feature is that we actually can assign to the assign the ggplot into a variable and then add them up. So it's an interesting feature of the ggplot. So so now we have the Hamilton County, Tennessee daily cases. So you see here, the last day, wait. I'm only plotting to October. Oh yeah, that's January. January is not there yet. So that must be December. This 0 must be Saturday, December 18 or 19. Oh, December 19. Today is December 20. Yes, today is December 20, so that must be a Saturday, December 19, which has 0 cases. Oh, you see there's also a negative number. Of course, there's really no negative cases, but apparently sometimes the county will adjust their cases, especially in Hamilton County, the major hospital will accept patients from out of county. So sometimes they will, like some will say this patient doesn't belong to us. They should belong to other counties. And when they make that kind of adjustment, the daily cases actually can be negative. So yeah, unfortunately, that happens. So yeah. That's just an indication to say the real data sometimes do not make sense in the scientific sense, right? If you think of a virus that infecting people, what kind of case will become negative? I actually can't hard imagine that what that really means. But yeah, but the number, if you just look at number, they are negative number. So okay, so what we now have is the daily cases change from the probably March. What's my time window? April 1st? Did I start from April 1st? Somewhere in the beginning, we select a time window. Oh, I basically picked 300 days. Yeah. 300 days up to the most recent one. Yeah. So I guess that's the first, December 18 minus the 300 days. That's yeah. Okay. If you are not following, please pick indicate a red no. If you are you are following, it's fine. So
I had a question.
Yes.
So do these dots represent the daily number of cases or the new number of cases every day in Hamilton County?
Correct. Yes.
So why are there multiple dots? Are there multiple dots for the same day, or is it just they're so close together?
They are just so close. Well, if you want to plot a different range, let's plot in a different range, then you will see more. Let's change the time window. Instead of 300 days, I'm going to change, say, 90 days, 3 months, right? So, and then let's redo everything, right? So the good thing about the CoLab, you can actually minimize this and just rerun everything in the entire block. Okay, so once it's done, we can scroll back down. Oh, there. So now you have 90 days. So you can actually now look at it in a 90-day window. So yeah.
Okay, because I just got confused a little bit because I thought there were multiple dots on the same day, and thank you so much.
Yeah. So that's one of the advantages of writing the code is if you want to repeat, make some adjustment, you can just change a few things. In this case, I just changed 300 to 90 days. Right? Imagine if I'm using Excel to do this, then it will be a bit troubling, right? Cumbersome to do it, right? So you have to select a different range and then adjust a figure label. But here, since we are writing a code to let the computer do this, what we need to do just change a few parameter there, change a few value in our code, and then you rerun the code, and it will regenerate a new plot. So. Okay, so I'm going to, so this is chapter 4. Let me minimize that. So probably the best, one of the most effective way of preventing the virus spread is social distancing. And one of the way to measure social distancing apparently is mobility, which is based on the cell phone movement signals. And since many of the people using a Google map, so apparently Google actually knows many people's movement, including mine, I guess, because I use Google Map quite a lot. So every end of a month, I actually receive a report the places you have traveled. So yeah, so one way to estimate the social distancing practice at the different location is actually Google provides something called Google Community Mobility Report. So that's if I click on that link, there, see how your community is moving moving around differently due to COVID-19. So apparently, Google records the mobility signal before and after pandemic. And so before pandemic, they have some how the cell phone moving location. And then during the pandemic, they compare the movement with the pre-pandemic. And then if it's increasing, it will be more than 100%, I guess. If it's decreasing, it will goes down. So they are reporting something called a percentage change. So, and since that data is provided there, the zip file, I believe. So if you actually click on that, it's actually going to save it on your own computer. But since we are using Google CoLab, we can actually get it, instead of downloading it to your own computer, we can download it directly into Google CoLab too. So there. Once you click on that, it actually download a copy of that file into your CoLab content folder. So if you actually look at your own CoLab page, you see some icons. That's the table of content. And then at the very bottom, there's a file. Once you click file, sometimes by default, it actually shows in a content folder. So if you go to the, oops, sorry, that's upload. I clicked the wrong one. So if you click the two dots, actually goes up one level. So this is the content folder. That's actually where your data, your own customer, your own data is there temporarily on the CoLab. So that's the Google Regional Mobility Report in CSV format. But it's actually compressed zip format. So we need to unzip it. If you download the zip file on your own computer, sometimes you can double click. In Windows, Windows or Mac computer, you can just double click to unzip that file. But on CoLab, we need to run this command called system unzip, and with the address of the file to unzip it. Hold on. Oh yeah, see, after it takes a while for the file to show. It actually have a lot of file inside of that. But the good thing is let's see, YMK and U. It is really a lot. Oh, this must be also by country, I guess. I don't remember exactly what those files are. Oh, where? Here. This is the US, hopefully. So I think that's, yes. So we are going to use the US regional. I guess those are all different countries. So yeah, I didn't look at all the file, obviously. So we're only looking at the US regional report. I wonder, I guess every country have a letter code. At least Google gives it. So, yeah. So this is the Google Mobility Report for the US regions. So we have the state, and then we have the county there. State, this is Wyoming, a county, and then again, you see the census FIP code, and then you have a date, and then you have, so the Google actually has some interesting report. It actually reporting the mobility change in grocery, retail, and the recreation percentage change, and then from the baseline, which means pre-pandemic. What is it? Grocery and pharmacy. Okay. What is this? Parks. Okay. What is this? This what? Transit stations. Some other workplace, and what's this one? Residential. So the workplace and the residential is the one we are going to use. Some other mobility, actually, Google even stopped the recording. So some of them, especially when in a whole lockdown, you are not supposed to move. So the park will be completely nothing there. So yeah, so the park is closed, right? So so again, now because Google have make their own report, so Google decide how to report their own data. If you look at this data, you realize, oh, this is actually, each day is actually a row. So this is also different from the Johns Hopkins data set. The Johns Hopkins data set, you remember, each county is a row, but here in the Google report, we have the Western County from Wyoming, but the entire row is from that place and on that day. Right? So the Google report had a different format from the Johns Hopkins data set, and we need to convert those reports, make them merge with the Johns Hopkins COVID-19 data set, and then overlay them. So this is the part very often we call it the data wrangling or data pre-processing, whatever the name is. It's actually one of the most important skills in data analysis. In fact, if you talk to people working in the industry, they will say probably 80% of people's time is spent on this. This is because in the real world, people going to generate a report in different format. And if you want to analyze all the data, you need to so-called harmonize all the heterogeneous data set, put them together, and then analyze them. I see a question say chapter 4 we have a problem. Which cell oh, I see. Right now you do not want to. Right now you don't want to change the. You only. I guess you can start working on it on Monday when you are trying to do that for your own report, and you can also do that after class at the end of this. Yeah. So. Okay. I see. This okay. There are some very interesting questions there. Good that it's good that TA are answering that. So I'm not sure. Chapter 4. It seems to be is running on my side. If people have trouble to running, let's which cell you have trouble to run?
I think the issue is that in one of the cells you wrote str and then x, so you took the structure of x, but there was no object x when you were making the graph. But I think that's just like you can just ignore that.
Sorry, that's a typo. Sorry. Oh, how did that happen? Thank you.
Was anybody else having any similar problems with that?
Yeah. Okay.
Okay, yeah. So I think you're good now that, yeah, if you just take it out, it should not impact your script.
Yeah. So, okay, thank you. Wow, I never noticed I have a typo there. So, thank you. Yeah. Okay, so hopefully that will, once you remove that X, then it runs. So, okay, so. Okay. Oh, some is asking why there is Wyoming there. We are just looking at the last few rows of the Google Mobility. So if you change that to the header, it's probably going to be Alabama, I guess. Actually, let me not. I'm going to add a new line at the bottom. There. So, oops. There's actually nobody. So those are blank regions for some reason. Not sure why that's the case. So I guess that's why I picked the last few rows. So obviously the first. Oh, I guess Google also provide a generic average. Maybe that's the why. Yeah. Yeah, I didn't read the. I guess if you really want to understand this, you can go back to the Google page and try. If I just take a wild guess, that's probably just the average number for the entire U.S. as a country. I guess that must be the average. Yeah. Okay. So, but here we kind of pick Tennessee, Hamilton County. And the naming of the county is also different in Google. Google actually added that county as a word into the county name. So Hamilton County, Tennessee. That's how Google named the county and the state. So we're going to pick Hamilton County from Tennessee, and then pick the mobility data from Hamilton County, Tennessee. Okay. There. That's Hamilton County, Tennessee. Google mobility data. Retail, you see some negative change. There are some fluctuation. Parks, well, apparently in early spring, wow, the park, we have some really active park. I guess that's actually before lockdown, so yeah. You can see a lot of, I think that means a lot of people goes to park, positive number. So maybe that's a weekend, February 15th. Let's look at the most recent data, tail. That's it also, apparently the Google mobility report is actually not on the daily cases. It seems to be, it has some latency. There's some delay. So the most recent data Google report mobility is actually December 15th. Right? So the Johns Hopkins actually report that data on a daily basis, but the Google mobility, apparently the most recent one is December 15th. And okay, look like the retail all negative in last, but still it's actually just small percentage. Grocery, really not much changed. Parks, actually, it looked like okay. But transit, I still do not know what transit station means. But workplace clearly goes down. It's also a holiday season, so what that really goes down, I'm not sure. But the residential actually is increasing, you see here. So. I think if you the question how the percentage is determined. My understanding, they have an average number in regular years before the pandemic, and that's where the part at the bottom of the fraction, and the current mobility will be the numerator, which is at the upper part of the division operation. So that's my understanding. And then if it goes down, it's negative. It goes up, will be positive. But we can just use that number as the measurement. It's approximation. Yeah, this is not a good. There's not much. There's no perfect way to measure social distancing, right? So social distancing is at the very bottom level is the individual practice, right? So, but then you have to come up with some number for a county or even for a country, how people in general practice social distancing. So it's a bit of a, oh, I see, there's a chat. It's a median value, yeah. So apparently, it looked like Dr. Ray Sanchez Arias really read the website. So it looked like the Google actually have a daily average during the week, because obviously Monday working day and the weekend will have a difference in the workplace and the residential and the park mobility travel. So so they do have taken consideration of weekday into consideration when they calculate this. So, okay, so that's the how many measurement. To be honest, I think Google is trying a bit too hard on this. You have a metro area, retail, and retail, grocery, park. Transit. It doesn't always work for every location, but it's okay. So, and the most recent one is December 15th. Yeah. So, But now we need to merge the Google mobility data and the COVID-19 data for Hamilton County, Tennessee. So, and let's first see what's the format of our COVID-19 data. That's the COVID-19 from Hamilton, Tennessee. Oh, now I also use a 90-day window now. So, and the mobility. So because after we merge, everything will be Hamilton County. So I changed the name of this into daily cases and dates. So, but the mobility, I thought that, let me see. Now we use the merge function. Actually, I forgot to change this. Let's just merge the function. Mobility with COVID-19. So we use the rmerge function. The merge function basically merging two data frames into one using a keyword. Using a column, a shared column. And in this case, the shared column is the dates. This is because the Google mobility using date, and I also changed the COVID-19 column into date. So we're going to using the date column to merge the two data frames. And you can ignore that for the time being. And right now we're just taking the shared data into it. So let's run that and look at the tail command. So we also renamed the merge the data with the dates too. So there. So we now have the merge that will be the initial will be the first part is look like is the Google mobility data. Hopefully the end. Wait a minute. What other cases? Oh, sorry. I read it wrong. The first part actually is the daily cases here. And then it's the Google mobility data. Yeah. So there, that's the daily cases here. It's actually not the end. My bad. That's the daily cases, and then dates, and then the row name. So now we have 15 columns. But if we want to overlay them, we overlay 15 columns of data is kind of a bit of confusing. So we are going to select only the values to plot. So look like the second column is the daily cases. Second, third, fourth, fifth, 7, 8, 9, 10, 11. 11, but I select a 10. Why is it? Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it is 10. I must count it wrong. Yeah. So, so the value is actually the second, and then 10 to 15. Those are the values. So we're going to select the actual values for the other information like US, United States. If we plot them, it doesn't make any sense. So let's just remove them. So we call rename the column TB, Google Mobility, COVID-19, and our county number 2, just to know that's the new data set new data frame we have. So after we just select those value columns, now we have daily cases, retail and recreation, grocery, parks, transit, what is this? Workplace and residential. Yeah. So, okay. So now we actually have the actual numbers there. We can plot them. But let's say if we do the plot, you realize we have something 67. We have another thing -9, -4, 0. If we actually, and then we also have 47, 14. If we do this plot, then things will be all over the place, right? So if we want to overlay number in different range on the same figure, one way is so-called normalize. We normalize everything between 0 with a mean of 1 and a mean of 0, and that's between -1 to +1. So that's what the normalization means. And in R, we can just use the scale function. And so we can just use the scale function for normalization in R. Yeah.
Excuse me, Professor Chen.
Yes.
Why do we normalize the data set again?
Okay. If we don't normalize the data set, you will have because we want to overlay all this value on the same figure, and then we are going to overlay numbers in a range of 67 and in fact several hundred, and then we also have number between 0, 1, 2. When you plot all this the number in different range on same figure, those number are in large number going to overshadow the number with a small values. I guess like if you want to overlay say for example, if you want to overlay some data like in miles, and then with something like in inches, right? And then because if we put these two numbers on the same plot, the miles is much larger than inches. So even inches change from 1 inch to 2 inches, you change it by twofold. But the mile going to overshadow all those small numbers. So if we want to see how things change at their own level, it's usually a good idea to normalize them first, put them on the same range.
I see. Thank you.
Yeah. Oh, there's a good kind. We normalize things because we want to compare them on common scale. Thank you. That's a very concise explanation. Yeah. So yeah, that's the Marla Harlan. Oh, sorry. Thank you. That's a very concise explanation. Yeah. So okay. So we normalize all sorts of values, and then actually we cannot normalize the date. So when we normalize it, we leave the date out. After normalize, we add the date back. And then we can overlay them. But there are so many columns here, and we are going to only pick what column to overlay: the daily cases, retail, workplace, and residential. And you can, for the timing, you can just ignore the detail of the plotting, because as long as you change the column name, you will have the plotting. Oh, well, that's still quite a lot in the plotting. So if I briefly explain it, we have to first map, because the ggplot what it really does is still doing a two-number plot, but what it can do is, so when we do so-called overlay, we have to put those separate columns into one column first, but then label them with different color. And personally, I think this is still something need to be further developed in the ggplot package. I think that so people don't have to go through this step. If I'm the software developer, I think ggplot need to add some further features to make this much simpler. Right now, this is a bit awkward to do in ggplot, but that's just the way it works now. So, and for now, you can just ignore the detail. As long as you can change the column name, it's going to work. So, okay, so this is what we have now for the that orange will be the daily cases at Hamilton County, Tennessee. That green is retail and the recreation change from baseline. Retail recreation. There's a recent dip there. I'm not sure. Isn't that a Thanksgiving holiday? Why Thanksgiving? Oh, because all the stores are closed. Okay, that makes sense. And then there's also a workplace goes down because Thanksgiving holiday, nobody works there. And then residential. Oh, but then interestingly, of course, during the Thanksgiving holiday break, the residential mobility increase. So even though people do not travel for work, it look like people travel for parties, holiday parties. So there. And the daily cases is this orange line. You can actually see a little a peak over there, but this. Let's say that if we do a 90-day plot, it's actually not very informative. So I'm going to go back, change the 90-day plot into a 300. So then we'll have a longer range. So I'm going to minimize. So the good thing about the ARCO, we can just change a few parameters and then redo the analysis. So I'm going to change this back to 300 and then just rerun everything. Okay, so I rerun the daily cases and now I'm rerunning the mobility. So now let's look at this again. So now I have a 300-day window plot. So it looks like, okay, so it looks like the peaking, this is actually the second wave in the United States. The first wave is early March, but the Tennessee is spared in that first wave. And then, but Tennessee was hit by the second wave, which is early summer. And then it goes down in late summer. And now it's picking up. So, and the shutdown in Tennessee is probably in late March. So you see the workplace and the residential place all goes down because that's the stay in shelter order. So, that's really bringing things down. But then the business reopened. So you see the workplace mobility goes up, residential, actually, even in the shutdown, you see the residential mobility actually goes up. So, and then the residential mobility goes down when business reopened. So, and then we see, apparently in the holiday season, now the workplace goes down, which is as expected. Right? So many places close down for the holidays, but the residential actually goes up. So this is the Hamilton County, Tennessee. So okay, questions? Okay, so so that's let me minimize. So let me go back to the chapter and minimize this chapter. So that's chapter 5 for the Google mobility analysis. And the next chapter is really my favorite. We can also, I mean, why does the cases goes up and down? In fact, if you Google, you see a lot of discussion about how the weather will impact. In fact, the COVID-19 is one of the things we call seasonal infectious disease. So seasonal by definition means it's changed by season, right? At least that's my understanding. Otherwise, why we call it seasonal? So that means when the weather change, you expect a different pattern of the infectious disease. So, and then it'll be interesting to see indeed whether the weather is changing under the infection, the infectious disease cases also changing. So, so we actually can get weather data from the airport and all the what they call the NOAA station. Now, this is the part actually a bit tricky if you want to do a different location. That means you need to find out the latitude and longitude of your location and then look for the weather station you can use. I mean, maybe in the future, everybody's cell phone can do that, but currently we do not, right? So we're actually, usually it's the airport record all the weather information. So for Hamilton County, Tennessee, the closest airport is at the Lowell, Tennessee, and it had the latitude of 35.03 and longitude of minus 85.2. That's the, because how do I find out that? Well, you can use Google Map, or you can do a Google search. So call it. There. So Lowell, Tennessee had a latitude of 35.89. Actually, that's a bit different, is it? What number did I got? Well, it's good enough. So 35 north, 84 west. So this 85 west, when you input it, it has to be called negative because that's in the western part of the globe when we design this geospatial information system. So, okay, so we are going to try to look for the weather station from what? Latitude 35 and longitude, which is minus 85. Oh, I forgot to do that. And first, I need to install a package called WordBat. And please do that now because it's going to take about 10 minutes. Sorry, I should click that button a while ago. So, and then well, since we are waiting for that to happen, we can actually look at the NOAA website. So, yes, not a second though. 10 minutes will be 10 minutes, about 600 seconds.
So while we're waiting, I'd like to ask a question.
Sure, yeah.
So on the final video thing, will we be running R on CoLab, or will we be running it locally on our computers, or does it not matter?
It really doesn't matter. You don't even have to run R at all. It's the video presentation about some story, COVID-19 cases. You can just present the figures. Yeah, it'd be great. You can also provide your code and how you run it. Yeah, it's your own. You can decide how you do your video presentation. Yeah, but the topic is hopefully the the topic is about you write some code, generate some data. There's a figures, and then there's some local stories you can tell. Right. So it's about the how to tell using the data analysis tell a story, and
So could we just have like a timeline of the COVID cases in like a certain area and just show how it progresses along with world events? Or,
yeah, that would be interesting. Yeah. So
yeah, I was just curious about that.
yeah, that would be one idea. Yeah. So especially for some, I know some places they will have a very large event, right? So, right, if you some place actually have some so-called a super spreading event. So, fortunately for Hamilton County, Tennessee, there's no such event we can identify. So, but there are some cities they do have this so-called super spreading event.
Well, I was also wondering if we could use our own data because I've been collecting. My school posts the COVID stats every school day, and I was wondering if I can use those statistics for my video.
Sure, yeah, yeah, you could, yeah. That's it. I still wish you can plot your own figure. You don't, if you use the figure generated by your own school. It seems like in a way you are presenting a story, but I guess the main point, educational point here, I wish you use some of the skill we presented here in and the result in your presentation, I guess. Yeah. So
Well, if we were to convert their statistics to a CSV and load it up in R and show proficiency in R, would that be acceptable or?
that would be perfect. Yeah. So yeah. So by the way, since we are waiting, if for those who haven't who joined later in the session haven't signed in and finished the survey, you can also go back and sign in and take the survey. So, it's actually done installing on my side. Okay, good.
Dr. Chen, I think you sent that survey link directly to me.
Oh, I didn't send to everyone. Sorry. Okay, thank you. Okay, so okay. The good thing about I changed the code so it only install once. If you try to run it once, it actually only install once, so you don't have to wait more than 10 minutes, I guess. Yeah. Okay. So now we have the library world maps. We can actually look at the weather station near Lower Tennessee. Actually, the first one is Lowell Field Airport. So not surprisingly. So and then we are going to just pick the closest one. I don't. That's actually U.S. Air Force code and W Bank. I don't really know why there are two different codes for the weather station, but that's the two code we have to use to pick the weather data. So yeah, I guess you don't have to care about that either. So basically, this is almost like a social security number for to get the weather data, and we are going to use that two code and just import the data from the NOAA database. What is NOAA, by the way? If you right click on that, NOAA surface meteorological data from NOAA, but still, what is NOAA? Well, you can a National Oceanic and Atmospheric Administration. Oh, that's really a handful to pronounce. Okay. Anyhow, that's where you will get NOAA had a database. To be honestly, sometimes the government database doesn't work. Let's hope it works today. So let's hope it works today. For some reason, this NOAA federal database, sometimes if you want to get something, it actually doesn't work. Okay, it looks like today it is working. We got yes, we got the weather data. Yes, very good. Today is working. So we have the air temperature. There's actually a lot of things. I don't even know what they mean. Well, you have a latitude, longitude there. That's where they are recording this elevation. Some of the column I don't even know, but we only need to pick a few things. We're going to need a date, temperature, dew point, and RH, which is for relative humidity. That's 3 column is enough for our weather study. So, okay, so yeah. In fact, you'll see there are many things there. Actually, they seem to have precipitation, but we are not using that. That's that. So again, we are there. So we are just plotting which one, dew point, date and dew point. We could change that into the temperature too. So that's the temperature change from January to the most recent. The weather report is probably which date? Oh, is that head? Let's change that to tail. See what's the most recent day. Why the tail is not working? Now it's working. So December 17. Okay, so this is actually also not most update, not on the date. Oh, that means they don't work on weekend as well. So, well, it's a governmental agency. So, December 17 is the most recent date. Yeah, so so let's see. We are going to trying to only use the temperature, dew point, and relative humidity, and then we are going to what? Merge this with the COVID-19 cases. And to do that, we also need to reformat the date. Currently, the date is using a different format. In fact, because for airport, they recorded the temperature and the date on hourly basis, right? It's like midnight, 1 o'clock, 2 o'clock, 3 o'clock. So they are reporting the temperature on an hourly basis. But we don't have COVID-19 data on hourly basis. We only have it on daily basis. So what we're going to do is we're going to average those values and then overlay with the COVID-19 daily cases. So basically, we first, actually that's just the NOAA used to report the time with UTC, with Universal Times Conversion, something like that. But now you look like they remove that, but I still have that code there just in case they put it back. So, and then we actually can average the date, estimate the daily average of the weather. So, and that's actually can be done by the group by the okay, it looks like I have an error here because that's date, and now I change that to group by, that may give me an error. They didn't. That's interesting. Oh, because I have a different date, YMD. Okay. Oh, that's the. I see. That's the. I confused myself. That's the hourly time. This is converted year, month, and date. So we average by year, month, and date, and then remove the hourly time point. Okay. So then we have the daily average of the temperature, air temperature, dew point, and relative humidity. And then we converge the daily weather data with the COVID-19 daily cases. So the COVID-19 also have the mobility data too. And that's the, yeah. And then we can again use the merge function, merge the COVID-19 Google mobility with the weather data. And using what? Using the YMD. So yes, so it looked like I also renamed the COVID-19 data, the dates with YMD. Otherwise, it's hard to merge them. So wonderful. Yeah. So now we have a new data frame called TB_local. So we have the year, month, and date, and then we have the daily cases. That's for the Hamilton County daily COVID-19 cases. And then we have the Google mobility. And at the very end, we see the air temperature, dew point, and the relative humidity. There, we have three. Now we have information collected from three different sources. So COVID-19 from Johns Hopkins data, Google mobility, well, from Google, and the weather temperature from the NOAA, federal agency. This is actually also one of the advantage for writing code and do data analysis on our own, because now we just get the data from different sources. We know we converted them and do something interesting, which you cannot do using just a single data set. So you can actually look at the data set here. So we have the date, daily cases, retail, grocery, park, transit, workplace, residential, air temperature, dew point, and relative humidity. So we actually have 11 columns of data now. That's actually a bit confusing because for such a long name, it's really hard to use. So one convenient way is actually we rename them with the shorter names. So we're going to call it, well, YMD is short enough, daily cases. And the retail, I'm going to just call it retail. The grocery and the pharmacy percentage change from baseline, I'm going to rename it just grocery. Basically, everything is the first word look like. Parks, transit, workplace, residential, well, air temperature, dew point, RH, those are okay. So we're going to rename those. And then if we do that again, okay, so now we have a, look at the top one, because the column name is so long, it's even hard to read. By the bottom one, now we have a much shorter column name, so it's not much concise. So, yeah. And I'm going to pick, since Hamilton County, Tennessee has a lot of zero at the beginning of the year, so I'm not going to start from the January 1st. So I'm going to start from what? March 1st. That's actually still a lot of zero there, but it's fine. And then we're going to pick, well, today is fun, but really it's December 15th is the last day. So maybe I change that to a December, the end of the day. Because there's no data from the there's no weather data there. So I'm going to change the last day to December 15. Otherwise, there's no plot there. So, okay. Okay, so that's head. Change that to tail, see whether it is December 15. There. So now we have the time window from March 1st to December 15 for daily cases, mobility, and the weather data. And now we can overlay the cases, weather, and the mobility. So plot cases, mobility, and weather. So, and we also scale them first. And if I don't know the scale, you can see, well, then you have several hundred with a few numbers, then will be really hard to see. So, yeah. In fact, for comparison, if I do not scale, let's just do a comparison. Let me do a plot without scale. You will see why scale is important. So I'm going to just change that, remove the scale, and then redo the plot. There, so you see a plot like that. So the small value, like the residential, will look completely just a flat line. That's because the daily cases is changing on the several hundred scale. So yeah, that's the bottom plot without scale. At top, that's the scaled, normalized, and then overlay them. And you see, you can actually see the more detailed features of the residential change. So, oh, sorry. Okay, so if you want to, okay, there's another thing I can do is I can update my code directly on the website. So I'm going to say update during lecture, and then if you actually go back and click this code again, you will have my new copy of the code. So. Wait a few seconds for the website to refresh. Okay, so yeah, so if you reclone the code to your Google Drive, and this you will have exactly the same version I'm running now. So it is the same link I posted on the website. So. Yes, so you can. There are actually a lot of features in ggplot. You can actually there are entirely different courses and books to teach you how to do visualization. Yeah, so. Okay, I think I have finished all all the content I think I consider as the required material. Everything else was now optional. So I'm going to let you do the exercise. I try to modify the code, and then we can answer questions. And TA can also help you in breakout room, so we can have a more one-on-one interaction. So. Uh,
So about the breakout rooms, I'm looking here at the rooms and it doesn't really look like anyone's in there. Has their name and it says not joined.
oh yeah. So you need to for the breakout room you need to contact the TA which room you want to join. So right now nobody is in those rooms. And if you want to join a room where there's a every room there's a TA assigned there, so you can actually you need to message the TA. So I see Trinity Young trying to join room 3, and I also see Zarine Ahmed trying to join room 1. And
Yeah, those were from earlier.
oh, so far earlier. Oh, I see. Okay, yeah. So
Well,
yeah, I think it keeps you assigned in that unless you get like reassigned. It's just like which one you've been to before. That's why.
I see. I think you can just run pick. My setting is people can join their room directly. So if you pick a different room, you can go to a different room.
well, I was curious about that because it on my screen it just said not join, and I was just trying to figure that one out.
Oh, sure. Anyway, if people need help, you can click the red no button. Actually, would someone working on can someone share their screen? See how I'm going to start my sharing. Anyone willing to share?
Real quick, I think people are wondering what exactly we're supposed to be doing. Are we just supposed to be going back and looking at a different county right now?
Yes, you can. Yeah. So,
yeah. So we just go back to the chapters we were just working on and modify it for our own counties?
Yes, yeah. And for those who even want to work on their own school, that's actually a bit more challenging. You need to figure out how to read that CSV file directly into R or CoLab. So the easiest way, well, let me also try to modify my code. So what location you want to work on? Let's work for different locations. So let me save a copy. Let me save a different copy too. So. Okay, anyone have a suggestion? How about we try Puerto Rico? What places in Puerto Rico? Is it a county? How do I spell Puerto Rico? Okay, Puerto Rico. Is there a
also,
county?
Dr. Chin, if you could just like kind of clarify like the assignment for the students. I think that people are kind of confused on what the expectation is and what the like deliverable should be. So if you could just like kind of clarify what you're expecting, I think that would help a lot of people.
Very good. So let's so officially, let's see, UTC. So we actually provide so the reporting. You need to submit a written report for that $300 stipend. So here's the evaluation criteria for the written report, and in fact here's the template for the written report. Let's hope that the link works. Okay, very good. So you need to have a title, a first name, middle name, last name, your age, current grade, and which school you are from, city, state, country, an email for contact, and then you need to write a first abstract, about 100 words, tell the overall, and then introduction, explain what COVID-19 is and why what you are studying, probably the location, like where it is right now. Well, my report is for Hamilton County, Tennessee, but you probably study some a different location. And some other information, for example, I know in my case, well, I will discuss the lockdown and then reopening of Hamilton County, Tennessee, right? And then some method. In this case, we are using our CoLab, and then data frame, overlap, ggplot, tidyverse, something. And in this case, I'm going to put the overlay. For the method, you also need to explain where you get the Google Mobility. Well, that's where the Google Mobility is. And then I forgot to put a temperature there. The temperature data is from the NOAA. Actually, I think I need to add the temperature.
So I have two questions about this paper. So my first question is, how will the money be distributed? Is it going to be distributed by like gift cards or a grant or like money?
The gift card, sorry, the money will be given something as a consulting fee, because the University of Tennessee is the is the state university. Your report and the video will be considered from the university perspective. You are considered a vendor. You provided a service to the University of Tennessee, and the University of Tennessee will provide a payment to your report and video for a service. That's from the paperwork. That's what they look like. So yeah.
And my second question is, if we could work with anyone else with it, for example, someone else in this boot camp or someone from externally, like, would that be possible or not?
That will be your own decision. We only give people who receive stipend has to be U.S. citizen, and you need to attend the boot camp activity. So if you ask for, you can work with your parents or school, other expert. Yes, that's okay. But we only give to boot participant are U.S. citizen and legal resident. So, but you are of course the learning is not restricted to this. You should. And probably will be helpful too to work with anyone you think it's helpful for you to learn coding, COVID-19, or other things relevant, right? So.
All right, those are all my questions at this time. Thank you.
Mm-hmm. Sure. Yeah. Not sure how to know a data set. How to cite that? Anyone know how to cite that properly?
I actually could help with that, but I have a question first real quick.
Okay, sure, yeah.
So if we wanted to work with another student, like in the boot camp, would both of us receive the full stipend? Like if we submitted one report for the two of us?
That's a interesting question. I don't know. It depends, I guess. So, it depends on how many people will do that. Yeah. So we only provide stipend to 30 students, right? So if 40 students submit a 30 so that it depends. Unfortunately, yeah, I'm not sure. Yeah, so yeah, so people with green card, they are also they are legal resident. They are also eligible. So But two students working on the same project, I guess it is okay, but depend on how many. Depend on how many report and the video we have. Yeah. So Monday, Tuesday, Wednesday we have the same time slot. Yeah. So in fact I thought I sent out the Zoom. I can make sure I send out the Zoom. So Monday, Tuesday, Wednesday we have the same time slot, so you can come in, and then TA and I can help you work on your report, and probably also provide some feedback on your video production if you have it. Yeah. To get the stipend, you need at least a social security number, or so-called taxpayer number. Yeah. So if you don't have a social security number, then most likely you will not be eligible to receive the stipend. Someone said know how to cite a NOAA data set properly, but if you know that, put that in chat window. Oh, I see. Thank you. Okay, I put that.
Yep, that looks right.
Okay, thank you. Oops, I copied this wrong. See.
Yeah, citing sources is very interesting depending on what you're doing.
Yeah. Okay. So I'm going. Someone suggests a location. But it's a long list. I lost it. Can someone suggest the location again? Somewhere in. Oh, Cinderella, Puerto Rico. Okay, let's try that. Okay.
I want to make sure we understand the requirement there. Just to get a little more clarification, if you don't mind. So for the students, they are going to use the skills that we just learned, modify some of that code, and come up with their own way of providing analysis of a different location or some other way to rework that data and present it in whatever form they feel is right. And then for teachers, we need to take a look at this stuff and say, how would we create a lesson plan and actually use some version of this with our own students in the classroom? Is that correct?
Yes. You don't have to use this. It could be completely separate. You could like a Spelman faculty, they have a different thing. If you think this is too complicated for, say, middle school, you could come up with an entirely different thing. It's basically about I guess data science, quantitative reasoning, if you call it. Basically, some idea to teach basic data literacy. It doesn't have to be coding based, I think. Yeah. It's basically something. I guess as a teacher, the teacher knows what's the more effective way. In fact, I have no idea. So I basically gave you the way I teach R coding, but for anyone who teach their own student, I'm sure they know what's the best way to, the most proper way to work for their student at the right level, with the right difficulty or challenging, or depending on what you call it. Yeah. So.
Gotcha. But the focus being on data science and less about R coding. Is that correct?
That's correct. Yeah. So it's more emphasized on the exposure and the literacy, data literacy, something like that. Yeah, so.
Perfect. Thank you.
Yeah. So, okay. So I'm going to change my location to Sindra, Puerto Rico, and see how it works. So, oh, by the way, it's almost 3:30. You are free to go. So, but I'm going to change my code to Sindra literacy. I'm going to skip, go directly into the chapter 4. So, is that correct spelling? Sindra. Oh. I'm not sure whether that's actually works or not. So, but let's see whether this works or not. Okay, look, I made an error there. So how does it what is basically what is that number there? I hope there is a Puerto Rico there. I remember there is Puerto Rico, is it?
Excuse me, Dr. Quinn. Shin, sorry.
Yeah.
Maybe they don't have that data for Sidra.
Oh, they only have
Maybe.
Puerto Rico? Okay.
Yeah, I mean, I remember we yesterday we skimmed over the data quickly, and I saw at least some data for Puerto Rico, but I don't think they might have for every municipality in the island.
I see. Well, we can actually look at the spreadsheet directly and decide whether that's the case.
I looked at the John Hopkins data and I found Sidra.
You found it?
Yes.
Okay, let me open it up and see. I'm looking at that John Hopkins spreadsheet directly. See whether. Oh, I think I typed it wrong. Cedar, Puerto Rico. I don't see it. Okay, I think I typed it wrong. Okay. Change that to Cedar. Rico. Cedar. It actually does look like that's correct. Well, let's first run the first part. This part, okay. No, it's still have an error there. Oh, this part is okay, just printing that. So, oh, I need to first read the data first. Okay. I need to read the data.
Excuse me, Professor Chen.
Yes.
Are we supposed to be submitting both a video and a report, or is it either or?
It's both.
It's both? Okay.
Yeah. Oh, when I rerun this, it's trying to reinstall the package. Okay. Okay, but at least chapter 2 runs. Let's run chapter 3 again. Oh, yeah. Cedar, Puerto Rico. Yeah. So does that look right, Cedar, Puerto Rico? Well, it's not there anymore. It's a 600 December 19. Can someone check the Puerto Rico data, make sure that is correct? Okay, so now let's look at the daily cases.
The 600 was what, the new cases or accumulated?
That's cumulated. Well, that's a very small number. Okay.
Yeah, the last three numbers are 561, 586, and 600.
Yeah, that's cumulated.
Hopkins. Yeah.
Yeah. Puerto Rico seems to be very much in control now. So. Oh, I see. If that's the case, it's actually hard to, because you will have a lot of zeros then there. So. Well, there's some two digits number now, so maybe we can do a plot. So. Oh, that must be Cedar, Puerto Rico now. Does that look reasonable? So it does look like it's also increasing, but maybe you should change the date because that's there's a lot of zero even in April. So maybe we change the date into what day? 300, change that to 200, 250. Let's see. Okay.
So, question about the video: could we use audio or music that's copyrighted, or no music, copy free?
I would suggest against it, but I think you can find out the music, other material which are okay to use. They are music and video you can reuse, but copyrighted, I don't think.
Well, I was wondering because it might fall under fair use, but I want to know your stance on that.
Well, let's say that I'm not training any legal issues, so official status, I would say I have no opinion. But let's say I would recommend against it if there is a copyright issue there. So. but that said, I do see people doing what a meme or parody or many of the published fairly popular songs. So I don't know how that things work. So I just the other day I see people do what's that called basically they change the lyrics of some popular music. So I don't know how that works. Yeah.
Well, I was wondering about that because if I remember correctly, the thing said you could have a YouTube video or TikTok.
Mm-hmm.
And a lot of TikToks have copyrighted audio, so I was wondering about that.
I don't know that myself, but I guess officially I recommend you do not use the. If you know there's a copyright issue, you should not avoid using that. Even though many people are doing that, doesn't mean it's legal, right? So it's another thing saying that many people are doing that. It's another thing to say whether it's illegal or not. It's not the same thing. So just because many people are doing that doesn't mean you should also do that. So that's probably especially true even for the COVID-19 data we are analyzing. So but it does look like I now plotted the singular Puerto Rico data. It's actually still, even the highest is just 40. So that's wow. I don't know population-wise, yeah. But let's also look at the Google mobility, see whether we can get the Google mobility data there. It's actually quite interesting. I thought this probably should be in the where did I say change the? Oh, here. Okay, so I'm going to put Puerto Rico there, and then replace Hamilton with Singer. Not sure whether this work or not, but let's try. So. No, wait a minute, it's not working. Okay, so.
Can you hear me?
Hello, someone is speaking?
Am I like glitching at all?
Sorry, what? I'm going to first just pick the Puerto Rico and see whether this.
I have just a question before I leave. So, for like the project, so does it have to be specifically about, well, like is it just like related to COVID and tells an interesting story, and then is that like the parameters, I guess?
That would be it has to be something about data literacy or data analysis and what you have learned.
I mean, yeah, about data.
Yeah, it's not a general essay about COVID and viruses. Yeah.
It's like specifically, does it have to be specifically like on cases though? I guess is what I'm asking.
Oh, I see. I found out why there's an error here. So it had to be something about the coding, especially the report. Your video is just free from. Yeah. In fact, probably the video should be as entertaining as possible, I guess. So, but your report really should be fact-based, data-based. It cannot be a general speculation or reflective.
Like
Yeah.
related to COVID database, like as long as it's based on data and related to COVID, that's a good topic.
Like in this case, if I'm writing a report, I will be writing a report on the Sidra, Puerto Rico, right? So it's based on the analysis I'm working on. It's not based on the general it's not a news report, just I guess our essay, just say what has happened at the Sidra. That may cover in the introduction, but your result discussion really should need to focus on you did some analysis there. So I have a problem here. It looked like Google Mobility really doesn't have the Puerto Rico. Unless Puerto Rico is in a different report in Google Mobility. Google, so it looked like a Google Mobility put Puerto Rico in different places, probably. That can be a how do I spell Puerto Rico again? What if I just, now it come back. Well, Puerto Rico actually can be downloaded directly. So, that's a PDF. Let me download the US that data set directly, see whether it has or not. So.
I have a question.
Mm-hmm.
At the end of this program, do we have to provide you guys with our personal notebook of the program?
No, you don't have to. But all you require is the report. It looked like I just couldn't find the Puerto Rico in a Google report. The Johns Hopkins data set is quite straightforward, but the Google Mobility, I'm not sure where it put the Puerto Rico there. So maybe in the global. Let's try the global. But if it's global, then it doesn't have the county data though. If that's the case, we actually can skip the mobility, just go to the temperature of weather data. So Okay, let's just do the weather. See whether we can get the weather report from the Puerto Rico. So. Oops. Puerto Rico latitude, longitude. Oh, center. Okay, that's the one we're going to use. So. Excuse me. So that would be 18.2 and 66.2. Okay, let's hope it has something. It doesn't have the package. Okay. Oh, I have not run this local code. That's why. Sorry. Well, it's going to take 10 minutes to install the world map. So, yeah. Oh, so we have some very dedicated students still stay on. So feel free to leave. I'm actually quite curious.
Where are you right now so I can load that?
Sorry, what?
Okay, never mind. I found the package that I need to install.
Yeah.
So I'm trying the same thing, but with San Juan.
I see. Yeah. Where is San Juan?
It's also in Puerto Rico.
Oh, it's also in Puerto Rico.
Dr. Shim, was the problem with loading up any places in Puerto Rico, or what was the problem?
When I look for the U.S. Google mobility data, I cannot find Puerto Rico there.
Okay, gotcha.
Basically, where is Puerto Rico in Google mobility report? So I mean, Google had the PDF version for the report, so it has the data somewhere.
I was able to do it with Puerto Rico in Chapter 7, where it's explore the U.S. state level data. There it has the information of Puerto Rico.
Oh, that's for but that's for the Puerto Rico as the...
exactly, as a whole state, but it's not like specific regions.
Well, if it is, I guess that's another way. We can just do the Puerto Rico as the country. So.
Also, in terms of the report and for the video and everything, what you want us to do is to look at specific cities, or can we do it with the whole country?
You can do for the whole country. At least for Puerto Rico, I mean, if we cannot even find the mobility there at the country level, what's the point, right? So it's easier to do it the whole country, Puerto Rico as a whole country. Yeah. So.
Yes, perfect. Yeah. And so if I would use the whole country of Puerto Rico, would that mean that I would have to compare it also to an entire country like the United States? Because Puerto Rico is a lot smaller and we have a lot more density. Like the population density is comparable to that of Massachusetts. So that's why I asked.
I see. It's this is not a rigorous analysis. Just do it something more convenient. It's the fun project, not supposed to be It's supposed to be just a weekend leisure project, I would say. Yeah. So,
Dr. Shim, maybe we could merge the Puerto Rico and U.S. data sets together and then publish it up on the CoLab.
Sure, if you know how to do that, yeah. Where did you find it?
Yes, please.
Yeah. So,
well, I was just looking. I haven't found it yet, but it seems like it might just be under the content, under a different report.
Yeah, it's probably in a different file because Google Mobility has so many files. I don't know which one.
Yeah, I think I'll take a look here.
Yeah, thank you. Yeah, so let me go back. Is it still installing? Oh, it looks like it's finished. Okay, let's load that.
Yeah, Dr. Shin, I got it. It's you just had to change the US to PR.
Oh, okay, excellent. Let's
and I'm sure we could look at merging them.
Excellent. So I check go back to that, change the US
yeah, on that, the one below that right there, yeah.
Into PR. Okay, thank you. Let's see. Excellent, yay. Well, Trevor, you are problem solver. So, very good. So, okay, now let's see. Just try whether the whole thing runs or not. Huh, I still get nothing out of it. Okay. Oh, huh. That's interesting. It doesn't have a country after that, so I need to remove the country. I guess, so in Puerto Rico, Sidra is not a country, is what?
We have towns.
Oh, that's called, okay.
Uh-huh.
I still got nothing out of that.
I think that's the translation. Anybody from Puerto Rico can help me.
Okay.
It would be a municipality. That's kind of what. Yeah, that's kind of what we were.
Sub-region. I probably look for the wrong thing too. That's why. Okay. Instead of sub-region one, we now need to pick country region. I see. That's why. So we now. Okay, to just remove that. So we now pick sub-region one is. Sub-region, and the other one is my country, is it? Country region, okay, I see.
I don't know if this has all the data because that's the only sub-region they have listed.
Yeah.
I'm not sure how you pronounce that, but.
Well, let's find out, yeah. Nothing there, okay. Let's try it with just Puerto Rico as a country then. Okay. Okay, so then let's pick the sub-region and find out how many sub-regions are there. So this will be sub-region 1. Okay, let's find out. pasting. No, I guess I need to type the, oh, it's not selection, select. Oh, it's actually there, Sidra is there. So why I'm not picking it up? Well, at least we know Sidra is there, so.
I think it's filtering by the.
Oh, I have a
subregion 2, and there's no subregion 2 in the original code. They're the county region. It's county.
Oh, I made a mistake myself. It's subregion 1.
Yeah.
There's always the human error there, so subregion 1. Okay, let's hope this time it works. Yay, it worked. So I'm going to comment this because that's pretty long. Okay. So there we have the Sidra, Puerto Rico. Okay. And then it should just work. Sidra, Puerto Rico. Dates. Okay, let's hope. Oh yeah, merged. Okay, let's just plot it. Normalize and plot. Oh, that's normalize. Okay, this is plotting. Does that make sense? July, June, is that May? Daily cases, it is increasing too. Retail. Why we pick retail, not a residential? Well, anyhow. It looked like Puerto Rico like shopping. In 4th of July, there's a lot of retail. As a joke. So, yeah. Well, it's good that now we have the mobility, so we can actually get to the weather, and so let's see.
Professor, can you show again the filter for the parse the mobility data for the location? Like the county.
Actually, I can do it even better. I can save this on the website so you can have a copy of this.
Okay, great. Thank you.
Save a copy in GitHub. Oh, I actually have a typo there. So, I'm going to leave that typo there. So otherwise, it's hold on. Just not to embarrass myself. Let me correct that typo, then save it. Puerto Rico. Okay, that's the correct one. Sidra PR, live from lecture. Oh, there's a question. Did we do a time series analysis? No, we did not. We didn't. We plotted a time series, but we actually did not do time series statistical analysis. We didn't cover that. Yeah, a good question. For time series analysis, it's actually there's some special ways to do that. One way is called co-integration. Basically, instead of calculate the time, do a regression between time series value, we actually first calculate the difference and then see whether that difference is so-called a stationary or not. But we are not covering that. Yeah. So, okay, so I push it down the GitHub. There, actually, that is the GitHub. I'm going to send out a link to you. So. Oh, I sent it just to one person. Sorry, that's my mistake. Okay, that's the code I just write for Sidra, Puerto Rico. That's the, if you click on the
Thank you.
Yeah, so. A tutorial for time series analysis. If you Google, must be a lot. So GitHub is a GitHub time series. There you see there. So time series R, hands-on time series analysis. So there. So you can just Google time series R, you'll get it. So yeah. Time series is very important. Obviously, infectious disease, and then you also have what? Weather. You also have a what? Stock market. So, excuse me. Okay, it's almost 4 o'clock, and in fact, the TAs probably also have other things. Yeah, so everybody is free to go, but if you want to stay, yeah. So, yeah.
Professor. So I clicked on the code for CIDRA, and it said that I need authorization from GitHub, and then it sent me to a login from GitHub. Do I need an account for that? Have to create an account?
That should be the case. You should be able to directly clone it into the CoLab. That's hold on. Maybe I need to send to you the different link.
It said notebook not found when I click on the link.
Oh, I'm sorry. I sent it to a private repository. I'm sorry. Let me do it again. Okay. I sent it to my own private repository. I should send it to the public one. Sorry, my mistake. Let me do I forgot to pick the public one. By default, it go to my first repository, but that's my own private repository. What's the name of the bootcamp? How do we call? We call it R. Oh, here. Okay. Okay, let me do it again. Sidra PR. Code. Thank you. It's good that you tried that. Okay, this time it should work. So copy link address. So okay, I just sent it to the chat window. Can you try it again?
Okay, it opened.
Okay, all right.
Thank you.
Oh, sure. I hope it's helpful. So, okay, any other questions?
Will the remaining days in the camp be used to like work with the TAs if we need on our project?
Yes, that's precisely the purpose for the remaining days. Yeah. So.
Okay, thank you. Have a great rest of the day.
Okay, good. Bye. Any other questions?
I think that's all for now. Thank you. Have a nice day.
Okay, thank you. Trevor, thank you. Isa, thank you. Saeed, thank you. I see.
Thank you.
Oh, sure. Anyone have other questions? Hey, Cleo, thank you. Yeah.
Thank you, Doctor.
Sure. Oh, Dr. Lee, thank you. Patel, thank you. Hey, Miran, thank you. So. Okay. Hey everyone, I'm going to end the meeting now if there's no other question.
Thank you.
Sure. Okay, enjoy the rest of the weekend if you have it. It's 4 o'clock. You have 8 hours left for the Sunday. Bye, everyone.